Hello viewers, Mr. Nyati here, your presenter, and I'm back again with another video, which is basically a video on section C of the 2025 GCE Science Paper 2 or Chemistry Past Paper. And we're going straight into question C, C2, and this is also, you can find this on YouTube under Bharat Academy, or you can find this on Facebook under the same name, Bharat Academy, on TikTok under the name of Nyati Bright. So we move on to question C2. C2, when you look at it, is quite short. It's more like it's short, but with huge amount of marks for just a simple statement. So let's move on straight to the question. Silver chloride is an insoluble salt which can be prepared by reacting aqueous sodium chloride and silver nitrate. It's true. Now, what you need to understand as a learner, as a candidate preparing for exams, is that when it comes to nitrates, you need to know which of the salts can be prepared by precipitation, which salts can be prepared by what method. So when you are preparing salts, you need to know you need to acclimatize yourself with what we call the solubility rules. So when we talk about nitrates, okay, you need to understand that all nitrates are soluble, okay? But when you talk about chlorides, since that's what the question has prescribed, it has talked about silver nitrate. The other one that has been mentioned is sodium chloride. So when we talk about chlorides, there are only two chlorides that are insoluble, okay? So we have silver chloride itself, and the other one is lead chloride. These two are salts you can prepare by the process of precipitation. Now, precipitation is the process by which you prepare an insoluble salt by reacting two soluble salts. So you need to identify which salts are soluble. So in this case, for us to prepare this guy, we need to identify two salts that if we react, they are going to give us silver nitrate, which is a solid. And those salts, in the question you've been given silver nitrate. Now remember, all nitrates are soluble. In other words, they dissolve when you put them in water. And the other one is also sodium chloride, which is table salt basically. So when you react these two, they are going to give you silver nitrate plus another one which is silver chloride to be given, which is a solid, the precipitate in this case, plus sodium nitrate as another product, okay? So how do you write then an equation for this reaction? Well, what you need to understand is that whenever you have a double decomposition reaction plus CD, what will be the product? One thing you need to understand, the one you have started with to write, the one which is, I'll consider this side to be the first side. So the one which is on the first side, okay, on the first reactant, will combine with the one on the second side of the second reactant. I hope that makes sense. Let me repeat that. In this case, the position does not change. A still remains to be the first one. In this case, you can also start with C if you want, but it doesn't matter. So what I mean is this: A will be the first one to be written, okay? Then who is going to occupy this position? Of course, you are going to have plus another one. Now, who is the first one between the two? It is C and another one. So in this case, in double decomposition, it's basically an exchange, okay? It's an exchange. This one was occupying the second position on the second reactant will now occupy the second position on the first reactant, and this one will go on the other side. In this case, we are going to have AD plus CB. That is what you need to know. So in the case of silver nitrate, okay, reacting with sodium chloride, you can guess the products, okay, using this illustration here or this model here. What you are going to have is silver chloride plus sodium nitrate. There's nothing difficult, ladies and gentlemen. This is something that is simple. So this is what we call double decomposition. But we know that the intention was to produce a salt, which is a solid. So this type of reaction, or this reaction, is called precipitation. This one is a precipitate. That is what you need to know. Okay? So let's now go to the question. What does the question say? Well, the question is saying that describe how dry and a fairly pure sample of silver chloride can be prepared in the laboratory. How many marks have been allocated to that question? 4. So what are you going to do? So you need to come up with the 4 steps. Now, the way you are going to write these steps matters a lot. You are not going to start mentioning number 1, this is what you are going to do. Number 2, do not number those steps, but just write them such that those points, the major points, are coming out in your steps so that you get awarded with all the 4 marks. I hope that makes sense. So what are you going to do? The first one is that number 1, you are going to mix equal volumes of silver, where is the question? Mix equal volumes of silver chloride. No, this is an insoluble solid. So you are going to mix equal volumes of sodium chloride and silver nitrate and shake. Okay, you shake the mixture. After that, you are going to notice that there's going to be some cloud that is going to be formed. And what are you going to do? The next step will be to filter off the sodium chloride, the sodium nitrate, which has been formed as, because you have 2 products. One is a solid, in this case silver chloride, but sodium nitrate, which is in aqueous, which is a solution, is filtered off. So the second step is filter off sodium chloride so that you can remain with filter off sodium nitrate. There has been some mixture of words there. Let me repeat that. The second step is to filter off sodium nitrate so that you can remain with silver chloride on the filter paper. The third step is to use distilled water to clean the precipitate or the silver chloride. And the last step is to dry the silver chloride between 2 filter papers. Those are just the steps that you need to put there for you to be awarded with the 4 marks. So this is how we are going to write them. So this is the answer to the first question. You are going to be awarded with 1 mark on this one. For this one, mix 2 equal volumes of silver nitrate and sodium chloride in a test tube and shake. 1 mark. Filter off sodium nitrate and remain with silver chloride on the filter paper. 1 mark. Wash the silver chloride using distilled water. 1 mark. Dry silver chloride between 2 filter papers. 1 mark. So which ones are the main words here? The first one is mixing, reacting. The second one is filtration. The third one is cleaning or washing, and the fourth one is drying. These should come out clear and with a direction of command to what it is talking about. Okay, so we move on to the second question. B, write the net ionic equation for the reaction. In A, include state symbols. Now look at the mark allocation. You've been given 2 marks. What is this for? Number 1, state symbols. Number 2, the net ionic equation. Those are the things are going to be awarded for these 2 marks. So let's write question B. Question B. The net ionic equation. So here we are talking about reacting silver nitrate, okay, which is in aqueous state, plus sodium chloride, which is also in aqueous state, to give us silver chloride, which is in solid state, plus sodium nitrate. Now we are told to say we need to write this in ionic equation and derive the net ionic equation with state symbols. So remember, when you are writing ionic equations, you break these because these are ionic compounds basically. So you are going to write these ions in single entities, okay? So you start with silver nitrate. Silver has a valence of 1, so you're going to leave a charge there and in aqueous state, plus what remains here is nitrate. Nitrate has a valence of 1 and you have a negative there. Notice one thing. The one which is on the first, the ion which is on the first to make the compound, the one which is on the first side will always carry a plus. The one on the second side will always carry a negative. That's what you need to know. Okay? This will help you a lot. Plus, we break this one, we separate the ions. We are separating the ions. We have sodium ion, which has a charge of plus in aqueous state, plus the chloride ion, which has a charge of negative in aqueous state. This leads us to having, can we separate this? No, because the rules state that when you're writing ionic equations, you need to separate only those that are in aqueous. The rest in gas, in solid, in liquid remain the same, okay? So we can't separate these ions, we leave them as a compound in solid state. Plus, sodium has this ion, plus nitrate ion in this case has a negative charge, okay? So ensure that before you tackle this, the equation is balanced, but I knew that this equation is balanced from the time I was writing. So silver 1, nitrogen 1, nitrogen 1, oxygen 3, sodium 1, sodium 1, chlorine 1, chlorine 1. So it's already balanced. But ensure that that's the first thing you do before you start doing this, because you're going to mess it up when you just go into writing with using equation which is not completely balanced. So at this point, what do? We cancel out the ions that appear on both sides of the equation. Is silver, this is what you do, is silver appearing on this side, silver ion? No, we leave this one out. Is nitrate appearing on both sides of the equation? We look for it. Yes, it's here. We cancel this one, cancel this one. We come to sodium. Is sodium appearing on both sides of the equation? We have sodium here, we have sodium here. We cancel sodium. Is chloride appearing on both sides of the equation? No, it is only appearing on the left side of the equation. We leave it out. So after reaching at this point, you now write those that remain. So we're going to have silver ion in aqueous state. Do not forget the state symbols. Plus chloride ion in aqueous state, which led to the production of silver chloride in solid state. This is the net ionic equation. So what it means is that these guys were just spectators, you know, like a football pitch. You have 22 people playing plus the referee, 23 people playing football in a football pitch and running up and down tirelessly. Then you have those that are watching who are just spectators. So they are doing absolutely nothing except to give the morale to the players and all those things. It's the same case here. You have these guys who are just doing absolutely nothing in the equation, but they were just helping in the formation of silver nitrate. So this is the net ionic equation. We move on to the next question. what does the next question say? The next question says, C, use your equation in B, okay? This equation that has been formed, this equation where we have derived, from where we have derived the net ionic equation. We use that equation to calculate the mass of silver chloride expected, okay, if 1.7 grams of silver nitrate reacted with excess sodium chloride. So we are calculating the mass of silver chloride, which is expected, okay? So let's calculate the mass which is expected. So this is the equation that we are taught to begin with. Okay, use the equation in B to calculate the mass of silver chloride expected if 1.7 grams of silver nitrate reacted with excess sodium chloride. So sodium chloride was in excess. So we have the equation. There are two ways in which we can solve this, but I would rather advise you to go the shorter way to save time. So what are we going to do? We need to consider the ones that are players. We've been told that this silver nitrate, we have its mass, and the one we are told to calculate is silver chloride. So we have these two guys. So when we look at the mole ratio, the coefficient that we've used is 1, okay? But we are not going to go there because the route we're going to use is a bit simple. So what we're going to do now is to calculate, okay, by considering the coefficients. We know it's 1. So we're going to find the relative formula mass, because these are ionic equations. So what is the relative formula mass for silver nitrate? We have silver, which has 108, nitrogen has 14, oxygen 16. So we just call it to multiply by the number of moles. So here we have 108 for silver, 108 plus, what else do we have? Nitrogen, which has 14, plus, what else do we have? Oxygen. Oxygen is 16. 16 multiplied by 3, that is 48. So plus 48. What do we have? We have 170. So we're going to put this 170 here. This is the relative formula mass. What about for silver chloride? We know for silver it's 108. 108 plus chlorine, which is 35.5. What are we getting? 143.5. So 143.5. So now, what is the mass of silver nitrate? We now have the relative formula mass says here. So what is the mass? We've been given this mass, and its mass is 1.7 grams. What will be the mass this side? We don't know. So we do a cross multiplication, and the x is going to be equal to 1.7 grams multiplied by 143.5 divided by 170, which will be equal to, we do 1.7 multiplied by 143.5 equals that divided by 170. This gives us 1.435. So it will be 1.435 grams of silver chloride. This is the answer, okay? This is the answer, because the question tells us to calculate the mass of silver chloride, okay, silver chloride expected if this much of silver nitrate reacted with excess sodium chloride. That's what we are expected to calculate, and this is what we have found, 1.435 grams of silver chloride. The next question, what does the next question say? The next question says that calculate the percentage yield if 0.95 grams of silver chloride was obtained. So We have here the actual yield and the theoretical yield. So we need to identify that, okay? So we do the percentage in total. Actual yield over the one that we multiplied by 100%. When you do the math, for 66.2%. 2% of our percentage. Is there any question? No, I hope this is the question that will help you. Bye-bye.